Hey Savvy people, it's Savvy Nick here. Today we plan on continuing with the Python tutorial on python.org. Last stream we went ahead and went through classes. As you can see here, we have the previous topic. And with classes we learned quite a bit. How to create classes, how to use them. And today we're going to be going through the standard library. Well, a brief tour of the standard library. We're not going to get to every function today. There's actually the next section is going to be the standard library again, but part 2, because there's a lot to the standard library. So if you're new and stopping by to watch a stream today, please make sure to subscribe below and hit the notification bell for future streams. And also make sure to smash that like button for me. It really does help me out. So let's go ahead and continue here. All right. So this is a class that we created. Well, actually, that we used from the last tutorial. It was a complex class that just had a function here and something to initialize it. I'll go ahead and move over to lesson 12, where we can use to test out things from the standard library. So the very first thing I see here is import OS. So this must import a module called OS. And it says that this provides functions for interacting with the operating system. So this is quite exciting because with this module, we'll be able to work with the operating system. So if we look at the function call that they make here, they do os.get cwd. So this is current working directory, as it says, current working directory. And for them, it was C Python 38. So using this, you can tell that you can access your operating system. So let's go ahead and give this a shot. So I'm just going to do os.get, here we go, cwd. And let's print that out actually. So print, and let's make the function call inside of print. Let's see, what did I do wrong? Import OS. I think I did anything wrong. Unexpected indent. That's because it's indented for some reason. All right, that should help it. Change scopes around a little bit because of that. And you can see here that I am in the C users savvy directory. And sure enough, that's what it says down here too. And that's our first call to the operating system, and we got some information back. How exciting. All right. So moving on, we also have OS change directory, so you can change the current working directory. If you're familiar with Linux, some of these might be familiar. So you would be doing CD with this one, and PWD with this one, print working directory. OS system, so you can even make commands run in the system by using OS system. And here they're doing make directory and today. So let's give this a shot, see what happens. Will it work? All right. So if we do print, well, I don't need to print it. I'll be able to see it. But I wonder what happens if I do os.system, and let's just do the ls command to list out all the contents. And ls is not recognized. Yeah, I probably can't do that in here, can I? Well, I can, but it's not recognized. So maybe if I do dir instead. Oh, look at that. So not only did we create a folder, we actually printed out the list of the current user, Savvy. So these are really great functions to know. As you can see now, you can talk to the operating system, send commands and get information back, and even manipulate stuff on the actual operating system, which is a great thing to know how to do. So, you know, you could search for a file, import the file, and parse through it if you wanted to at this point with everything that we've learned up until this point. So it says here, be sure to use import OS style instead of import OS, or sorry, from OS import everything. This will keep os.open from shadowing the built-in open function, which operates much differently. So it says here, be careful not to use this, otherwise you're going to shadow another built-in function, and I assume that means overload it. Metsu, nice to see you there. Welcome to the stream. Thanks for coming. Glad to have you. All right, so the built-in dir and help functions are useful as interactive aids for working with large modules like OS. Okay. So dir, and then if you do OS, returns a list of all module functions. Interesting. Help OS returns an extensive manual for the module's docstring, so we can give those a shot real quick. So if I did print dir OS, let's see if we get some information about it. And we sure do. So we've used this dir function in the past. It just tells you all the functions available by whatever you're passing in. So this is an object called OS, and we pass it in, and look at all these various different functions that we have. Fsync, make multiple directories, one directory, open something, find a path, link, all sorts of system function calls that we can use. Looks like they even have utime, which that's time in microseconds, I would assume, from the system clock. All right, so what if we did, so we do help, and then we can see all these other functions available to us. I wonder if we could do os dot, let's just do rm. Let's see if that works. Well, there we go, like this first. Let's see if that, so yeah, we get some help here. Help on built-in function rmdir in the module nt, remove directory, and it gives you a function prototype. Tells you what it does. It removes a directory, and I assume, well, we can see more if we wanted to. There's plenty of information on it, so let me scroll back. Oh, you don't see it as well anymore. I can rerun it and just look at it. So it tells you a little bit about the function itself and what it does and what it expects on your platform. Well, that's really nice. I mean, that's an easy way to just look through documentation on functions. Let's keep going here. For daily file and directory management tasks, the shutil module provides a higher level interface that is easier to use. So we got import shutil, and then they copy a file. So they copy, let's say, a database to an archive database file. They move files. Very cool. So these are kind of just shortcuts instead of maybe writing out an entire string here of what command and what you want to pass and all that fun stuff. You can simply just run one of these built-in functions of shutil and then pass a few parameters in, and it does everything in the background. Very good. If you're just stopping by, please make sure to go ahead and smash that like button for me. It does really help me out. And we'll continue on by looking at wildcards for files. The glob module provides a function for making file lists from directory wildcard searches. Import glob, 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 and then they look for a wildcard with .py. This returns all of the py files located in a, I guess, in the working directory. So what if we did glob real quick? Let's give it a shot. All right, so we'll remove all this and import glob. And let's go ahead and make a call. I'm just going to print the contents of this here. So that's going to search for all py files inside of my current directory, I would assume, my working directory. Hey there, Sai. Thanks for stopping by. I'm glad you can make it today. Good to see you. All right, so I'm going to go ahead and do that. And apparently it did not find any py files inside of the current directory, which, yeah, in the current location, I guess I do not have any py files. That makes sense. What if I did, let me try changing directories to my desktop, and I think I have a Python directory here. Let's see if it works this time. So yeah, now I have all my py files that I have in this Python directory. So it's whatever your current working directory is in the terminal and wherever you're running your py program. So I have a bunch of lessons in here that we've been working on, and a prime number pi in a game that I was messing with. So very cool. There you go, glob. Moving on to command line arguments. You can import system and print system argv. Okay. So this just prints the arguments that were passed into the current working program. So that's just one way to check what was imported. Maybe you need to troubleshoot and see what the user's importing, or you even want to I guess it's really for troubleshooting purposes. I really don't understand why else you would use this, at least the sysargv. If you understand how the structure works there, there's really not a big reason to check out what the arguments are. Okay, the arg parse module provides a more sophisticated mechanism to process command line arguments. So import arg parse, parser, arg parse, argument parser, program top, description, show top lines from each file, parser add argument. Oh, this is a lot to digest. So when run at the command line, python top.py -- lines 5, alpha text, beta text, the script sets argument lines to 5 and argument file names to alpha.text, beta.text. Okay. So they're parsing what they're, well, I guess what they're really doing is parsing through individual arguments that get passed in from the command line, and what they can do is use the parser to go ahead and parse through each individual argument and look for very specific names. Let's see, one. Yeah. And it gets specific parts of what's passed in from the command line and can set variables based on those specific ones. When am I changing to Linux on the for the Python tutorial? I think I'm going to go ahead and finish this out completely here. Python. I'll finish the Python tutorial on Windows, and then I might move over to Linux for the actual setup. Honestly, I'm trying to look for ideas on my first Python program, so if you have any ideas, feel free to post them. I might just do a simple list in Python, just like I did with C and C++, and go through that and how it's done in Python as well. Really just for beginners to follow along. And we'll go through much of similar stuff, maybe Git, using Git repos and Git commands and debugging, as well as getting our first program ready, getting our environment ready, all in Linux. What do you think about that? All right, error output redirection and program termination. Okay, so the system also has attributes for standard in, standard out, and standard error. Okay, so you can change the error that a program displays. Way to terminate a script is to use system exit. Nothing new there. Very good to know. Matsu, thank you. I'll go ahead and think more about that, and I'll probably give more information by the end of this series here. So we're getting close here. I think we're on 10. We got 11, 12, maybe 13 chapters, and then I'll get you some more information on that. The re module provides regular expression tools for advanced string processing. For complex matching manipulation, regular expressions offer optimized solutions. Yeah, I think that's a good mention, Sai. So when only simple capabilities are needed, string methods are preferred because they're easier to read and debug. Okay, so we can use RE. We can import that. It's part of the standard library. And use regular expressions on a string. So this has a regular expression, a string of a regular expression passed in. I assume you have to have this R in front in order to specify it is a regular expression. And then the find all function will find everything that pertains to the regular expression inside of a string on the right-hand side. Cool. Down here it says if you're trying to do really simple stuff, don't bother. Don't bother using RE, just use replace on a string. I mean, this could be a string variable. It doesn't need to be a literal string here. And then you can replace whatever you want inside of it. Just shows you two different ways. Not really two different ways, just a more advanced method and a simpler method. Mathematics. Everyone's favorite subject, mathematics. So what do we get with the math module? Sure, we get a lot, and probably a lot of stuff that we don't even need. So what, let's see, import math. They have cosine, log, random, and statistics. So in math, if you just open math up, you get, I would assume, all the fun stuff. So you get like exponentials, logarithmic, functions, so trigonometric functions. Let's see what else. Maybe square roots, exponents, all that fun stuff. Probably matrices as well. I don't know. Maybe, I guess you could just use what are they called? Maybe lists or dictionaries. Yeah, you got to learn the math somewhere though, so maybe you start on paper and then end up programming it. Not much help if you don't know what you're programming, right? Let's see. Random. Of course, we used the random function before. We used the random function. We were actually programming that rock, paper, scissors program, if you remember that towards the beginning of things. It was our first little game just that we messed around with. We went ahead and programmed that and used the random function and generated a random number between 1 and 3 to represent our rock, paper, or scissors. Yes, I unfortunately wish you could just upload it and boom, you know it, but not quite yet. So the random is of course great, and there's many different ways to use it, because you can specify certain ranges that you want to use. So again, we specified that 1 through 3 range. Here they're specifying a range between I assume 0 through 99 or 0 through 100, whatever that works out to be, 1 through 100. And perhaps that's, let's see, what's 10? So 10 just means give 10 out, I assume. So they got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 random numbers from this sample function. So this is kind of what we used before, I think. Random rand range. And said 6, so choose a number from, is that 0 to 6 or 1 to 6? I assume 0 to 6. And then the statistics module calculates basic statistical properties. So you can do mean, median, variance, maybe standard deviations, I would assume. Right now I see mean, median, and variance given here. So we have a list of data, some random numbers, floating point numbers, and those are passed into a mean function, a median function, and a variance, and then you get some output. Makes it super simple. Obrad, nice to see ya. Glad to have you again. All right, so internet access. Ooh, this one might be interesting. Does this help us with APIs? So there are a number of modules for accessing the internet and processing internet protocols. Yeah, okay. Two of the simplest are URL lib request for retrieving data from URLs and SMTP lib for sending mail. Wow. So what they've done here is they've imported a specific object from the URL lib request module, and then they wrote something here with URL open. If they open up the URL, and so this is some kind of a timer, looks like from I don't know, maybe the Navy, as a response for line in response, line decode UTF-8, decoding binary data to text. So they decode some binary to strings or text. If EST in the line or EDT in the line, look for Eastern Time, print line. So this URL must return something. Well, let's just check it out real quick. Should be able to just paste that in. Could not be found. Okay, well, we tried. Moving on. Import SMTP lib. So this has to do with mail, I would assume, SMTP. And look at that, yeah. So you can import an SMT lib. The server, you can set where the server is located. So this says on localhost. Then you can send some mail. There you go. And then you quit out. So I assume this creates a server temporarily on your localhost computer. And if you have internet, it can send out some mail. There you go. That's one way to spam people. Give it a try at some point. That's pretty cool. All right, dates and times. And this is what I really like about Python. I mean, they actually have quite a bit on the standard library that comes directly with Python. Don't have to go grab a bunch of modules that you don't have, or libraries or whatever. No Easter eggs. The datetime module supplies classes for manipulating dates, of course. So if we import, if we do import date from datetime module, then we can tell what the current day is, day and time, and this allows you to format the time. So string F time, I assume that stands for string format time. And here they're just here they're just formatting in a different method, so you can see the time in whatever way that you want to see it. So month, day, year, as you can see here. Then they have the day, the written out, right, in short form, month. Then they have the year, and is a day with a capital, I don't know, maybe a capital A. Oh man, capital T, so maybe it capitalizes the first letter, I'm not sure. But %A gives you the current day. And then they reuse %D, which gives you the current day of the month in an integer format, and then day of what month. I assume they just capitalize B, and then you always get a capitalized month or day. All right. And dates support calendar arithmetic. Okay, that's kind of cool. Age now minus birthday. So you can look and see how many days old you are instead of how many years. So you can take the now minus the birthday that they passed in here for date, which that must have translated it directly down to a specific, no, it wouldn't have. It just maybe takes, like, I don't know, epoch time or something. Some very long convoluted number gets saved into birthday, and some long convoluted number is taken from now and birthday, and then that's saved into age because you subtract 2 now from your birthday. It's not really, this isn't really your birthday. This would be the day you were born, so, well, sure, it is the birthday. Take that back. Age now minus the birthday. When I think birthday, I'm thinking every year you have a birthday, but the actual day you were born, now minus the day you were born, gives you how many days you are in age, and it just says take age, what we saved, which is some convoluted object, and just spit out the days from that age, and then you get a number. So there's something you can try real quick. Import the datetime function, put your birthday in, see what comes out. How many days old are you? Data compression. Wow. Common data archiving and compression formats are directly supported by modules including zlib, gzip, bz2, lzma, zip file, and tar file. So these are familiar, right? Zip, you're probably familiar with zip if you use Windows, tar if you use Linux. So you can use zlib to actually compress and decompress files in Python. And performance measurement, interesting. Some Python users develop an interest in knowing the relative performance of different approaches to the same problem. I think we actually, well, okay. Did we use this? No, we didn't use time it. I think we just used time before trying to get, if you remember with the prime number example, we tried timing the two different types of algorithm to go ahead and spit out prime numbers, which one was quicker. But for example, it might be tempting to use the tuple packing and unpacking feature. Okay, so they're just throwing, let's see, timer, TA, TB, PT. They're just testing. They're testing this inside of here. Timer. Test this. Time it. And that returns a time that it took to execute. It'd be interesting to go ahead and put a function call in here and just see how long a function runs. So this is, I assume that's what this is for then. It just times how long it takes to go ahead and accomplish anything inside the parentheses. That's a cool little function, no? Quick and easy to use as well. So for some quality control, So the doc test module provides a tool for scanning a module and validating tests embedded in a program's doc strings. Test construction is a simple and cutting and pasting a typical call along with its results into the doc string. This improves the documentation by providing the user with an example, and it allows the doc test module to make sure that the code remains true to its documentation. Define average of values, computes the arithmetic mean of the list of numbers, print average 20, 30, 70, 40, return some values, length values, import docstring, test mod. Automatically validate the embedded tests. Interesting. The unit test module is not as effortless as the doc test module, but it allows for a more comprehensive set of tests to be maintained in a separate file. Import unit test. Call test statistical functions. Define a function named test average self. Self assert equal. Assert equal. Okay. Not sure what to say about this quality control. So batteries included. Python has a batteries included philosophy. This is best seen through the sophisticated and robust capabilities of larger packages. Okay. So it's just saying it has a lot of modules already pre-built into it that help you accomplish tasks with various different elements of your operating system or the internet or whatever you're trying to access. So some of the stuff that they're mentioning here, let's see, email. They have an email package, so I assume you can use emailing. We already read about the SMTP lib, so you can send or receive emails from your Python program just with the standard library. It uses JSON. You can pack and unpack JSON, serial objects. CSV module that helps you, I assume, read and write files into a CSV format. Very powerful, like we said before. The SQLite 3 that even lets you talk to a SQLite database. All available. All right. So that's really it for our first standard library topic. I think we should continue on to the second part of this. We haven't been going too long here. Welcome back. Not Nugs. All right. 11. let's look at part 2. So let's see. Output formatting. The repr lib module provides a version of repr customized for abbreviated displays of a large or deeply nested containers. Okay. Interesting. So what it's saying is, I think you can use the REPR, the normal REPR, whenever you have a string and something that's not very complicated. It's a simple string. But if you have something like a lot of data inside of a list, dictionary, a set, whatever, that REPR lib with REPR can handle it. And what it's doing here is it's actually creating, I'm going to get this wrong, I can't remember exactly what these curly braces mean, either a set or whatever, but it's creating, let's say, a set of values from all of the letters inside of here. But using it, it's actually returning them in alphabetical order. All right, and then the p print. It's more sophisticated control over printing both built-in and user-defined functions in a way that is readable by the interpreter. Oh, look at that. So I remember talking about, I think it was Psi, that JSON objects can be quite cumbersome to read. So I think this is a very nice thing that you can use, pprint, which is pretty print. So you can have a complicated, let's say, JSON string or any kind of an object, really, list, dictionary, whatever, and use pprint in order to kind of print it out in a pretty manner. That way you can go ahead and simply debug and see how you want your object to kind of show up. Yeah. So this is something nice to know about. You can use pprint for pretty print instead of going to somewhere on the World Wide Web and searching for a pretty printer. Although that's what I end up doing anyway, because who wants to write this out? All right, the text wrap module formats paragraphs to fit on the given screen. Cool. So this is just some text wrapping that's available if you import the text wrap module. So it might look a little big as a paragraph, and if you use the wrap function, you can specify how many characters to actually wrap around on your screen. Another cool one. I mean, of course, we could be trying these out, but it clearly gives the example right here in front of us, so I don't feel like going through it. If there's any of them you want to try, you can go ahead and just go ahead and post it on the live chat, and I'll go ahead and give it a shot, or if you want to go into one for some specific reason. The locale is a database of culture-specific data formats. Okay. Yeah, that one's really not that. I mean, all of these have so many functions to them. Kind of hard to follow this one, but know that that one's available if you're trying to distinguish between different formats around the world. Apparently this module can help you do that. Templating. The string module includes a versatile template class with a simplified syntax suitable for editing by end users. This allows users to customize their applications without having to alter the application. From string import template, T template. Village folks send 10 to cause. T substitute, village equal Nottingham, cause equal the ditch fund. Nottingham folk send $10 to the ditch fund. There you go. So what this does is really, it just allows you to create a function template and then allow a user to fill in that function template, which then gets displayed in your program. So you can see what they did was they created a template. They filled in the template with this string and saved it as a T, a template object. And then it's probably just instantiating an object called template. So instantiated, let's say, an object called template, saved it to T, and then they called a specific function inside of the T object, which is now a template object, called substitute, and that allows you, as long as you know what variables are inside of the template function that you created, or template object, then you can go ahead and specify what you want the arguments to show up as. You could probably just get away with also just providing strings, and what that will do is the first string it sees, that can be filled in. So if you just put in Nottingham, it realizes that this is probably the first argument, village, and it will fill village with Nottingham. But the problem with that is if you switch those two, then the ditch fund will show up in village and the cause will show up as Nottingham. So it can be probably used as a positional argument, but the problem is you're going to get them in the wrong spot. That's why they call out specifically village and cause. Okay, so T template, they have return item to owner, D dictionary, item, unladen shallow, T dot substitute, D trace back most recent last call, owner. So the owner was not specified in here. So it's just telling you if you don't specify a dictionary with the values, the key value pairs, right? Or potentially just the strings like we did above, right? With a comma separated, then you're going to get a error that tells you, hey, look, you didn't give me the owner. I'm missing it. I need to know the owner. I need to know the item. Can't just specify one. I need both. Otherwise, owner doesn't exist, and I can't process that. All right, so template subclasses can specify a custom delimiter. For example, a batch renaming utility for a photo browser may elect to use percentage signs for placeholders such as the current date, item, sequence number, and file format or file format. So we have OS path. Looks like there's some files we're looking for, 3 images. Class batch rename template delimiter is going to be a percent sign. FMT, not sure what that stands for, but they named it whatever. So input, they're grabbing input from the user and the console. Enter rename style, %d date, sequence number, format, and enter. So that's what's going to be displayed to the user in the console, and we're waiting for an input. After we get the input, what do we do then? So you can see that they specified some input, right? They did Ashley _-n -f, and then batch rename takes the input, right? And formats, well, it gets a date. So it gets input, gets a date. So this is getting passed into a batch rename. Jeez. And for I, the file name in enumerate photo files, base, extension OS, path, splice text file name, new name, T substitute, D date, and I, F. So print 0 to 1 format, file new name, file name, new name. So, okay. Through this convoluted deal, what they're doing is they're taking any specified photo files and changing them to a format that the user gave. And for us, the %D meant date, %N meant some kind of a sequence number, and then %F meant some kind of a format. So this is a good way to translate names to other names based on user input. This one's quite convoluted, but cool. Let's say you have a bunch of files that you don't that you don't want to go through and manually rename. Well, here's a perfect way of doing it. It's definitely something we could try. I mean, get a bunch of images, process those images, and maybe I can do that later in a different video. All right. Well, I'm going to take a moment and just pause here. I'll be right back. I'm just going to take a few moments. Got to get some water. Awesome, Sai. Yeah, you should give it a try and let me know how that goes for you. I'm very interested in that too, because I can I can think of so many places where I have just a bunch of mixed files and maybe trips that I've taken and stuff like that, where I have pictures and I'd like to change the names in correlation to the trip that I had. So yeah, no, it's a really cool thing. Also, if you're new and stopping by to watch this stream today, please make sure to go ahead and subscribe below and also hit that like button for me. It really does help me out if you haven't already. Glad to have you. Let's see, working with binary data record layouts. They have a pack and an unpack module. I think no, we didn't look at this before, did we? So they import a struct, I assume that means structure, with open. They open up a zip file, and this is some kind of, I guess maybe readable, I don't know, as F. They save it as F. They read in data. They start is equal to 0 for I in range of 3. Start plus equal 14. So the increments start by 14 every time through this for loop. Field, struct pack, data start 16. So okay. So it looks like they're unpacking certain data from a file .14, so they go from 14 and they increment 16, maybe by bytes. Show the first 3 file. Maybe this is in relation to bytes, how many bytes of data they want to read in. And then they go through and let's see, fields. Yeah, they're just processing some kind of file, they're going through the file and they're searching for specific, I assume, information, bytes, whatever, and just storing them. That way they can go ahead and use that file directly into their program. So this is another one. They're using a struct. But I guess I'm a little confused where the, oh, okay, struct, unpack. Yeah, that's where it's used. It'd be nice if we had the actual data that they were trying to unpack. They didn't really specify that, so. Functions, maybe I should read this. Functions. The following example shows how to loop through a header information in a zip file without using the zip file module. Pack codes H and I represent 2 and 4 byte unsigned numbers respectively. The less than indicates that they are a standard size and in little endian byte order. Alright, so yeah, they're using this for a very specific file format, and they are parsing through that file format. So they're using a zip file here, and instead of using the module zip file, they're creating their own here. So just know that you can work with binary data. And multi-threading. Now this is a pretty advanced topic. So threading is a technique to decouple tasks which are not sequentially dependent. Threads can be used to improve the responsiveness of applications and accept user input while other tasks are running in the background. So think of this as not making your program quicker by any means. Think of this as being able to run multiple programs at the same time, all spawned off the same program. So multi is what they're, I guess, trying to say up here. A related case is running I/O in parallel with computations in another thread. So you could be reading inputs, outputs in, and running some type of algorithm on the other side. That way, those two aren't. They're running asynchronously. They don't have to be synchronized at all. They don't have to be in the same program or anything. I mean, they have to be in the same program, but they're going to spawn different tasks and work independently. A good example here, you don't want in your car, let's say, you don't want climate control to hold up your cruise control, right? If you had those two running on the same exact program without multi-threading it, or you would have a big issue because your climate control would be dependent, or actually your cruise control would be dependent on your climate control, which would be a terrible mess. So what are they doing with this? So import threading zip file, class A sync zip threading thread, define run, background async zip, start, join, wait for background task to finish, main program waited until background was done. Yeah, so I assume they're, with this function here, you can asynchronously zip up multiple files at the same time. Otherwise, I don't know why they would use this. Okay. Or they're just showing, actually, yeah. I mean, I guess you could, what I'm saying would work just fine too. I mean, why not start 2 of these at the same time? Instead of, of course you'd pass in 2 different text files and you'd zip them up, but what they've done here is they've just defined one side of things. They've defined one thread that's going to be focused on zipping up a file, and then you can be running a different task altogether. The principal challenge of multi-threaded applications is coordinating the threads that share data or other resources. To that end, the threading module provides a number of synchronization primitives, including locks, events, condition variables, and some force. Yeah. So if you got two threads that you got running and you need them to communicate with each other, the one's dependent on another, but you don't necessarily want one to hold up the other, well, that's where it gets a lot more complicated. And it's saying here that with their multi-threading objects, I guess called threading, they have functions that allow you to handle, handshaking between threads. This is important to know about whenever you're writing a huge program that's doing a bunch of things in the background, but we're not doing that. So moving on to logging. Logging is a module that offers a full-featured and flexible logging system. At its simplest, log messages are sent to a file or system error. Well, I like this because let's say you have a program and you're going through this program and you want to put a whole bunch of debug statements in it. Well, why not go ahead and put all those debug statements written out to a log file, a debug log file, instead of displaying them all in the console. It can get very cumbersome, backing through all of your console and reading all the output and formatting it and all that fun stuff. Instead, they offer a easy way to go ahead and log any information. So yeah. You can see at the simplest, log messages are sent to a file or to system standard error. So you can specify both, either or. If you want to, display it through your system, sure. If you want to put it in a file, great. And you can see what kind of errors that this actually produces here. So we have a logging debug info, warning, error, critical. And it only shows the warning, error, and critical. Don't know why they don't show debug and info. Okay, by default, informational and debugging messages are suppressed and the output is sent to standard error. So, gotcha. So the messaging doesn't care about debug or info since it's going to standard error, but you can change that in order to get those out as well. Weak references. So this allows you to track modules or objects without creating a reference to that object. Interesting. I'm going to skip over that one. I don't see where I'd be using weak references, so I'm not going to even think about it. All right, tools for working with lists. From array, we can import an array, sum A, array H. So many data structures needed can be met with built-in list type. However, sometimes there is a need for an alternative implementations with different performance trade-offs. So gotcha. So here, for example, the following shows that array of numbers stored as 2-byte unsigned binary numbers type code H rather than 16 bytes per entry for regular lists in Python int objects. So instead of 16 bytes, it's using only 2 bytes per stored integer, right? So we got 4010, 700, 2, 2, 2, 2, 2, 2, 2. So it's nice to know that you have the capability of using objects that specify, length. Maybe you have a program that's very running on a device that doesn't have a lot of memory. Well, this is a great way to go ahead and specify the specific amount of memory that you want to use, and import an array object and use that array based on, you know, whatever information you need. If you don't need to be storing floating point numbers and huge integers, then there's really no point in using up all 16 bytes per entry for normal integers. So this helps it get to like a C++ level of programming where you can kind of manage some memory. I think that's what this is really trying to show you. Collections provides a DQ object. Is like a list, but with faster appends and pops from the left side, but slower lookups in the middle. So this is so collections are basically optimized queues that allow you to pop and append quicker. But the trade-off is when you're looking up things in the middle, it makes it slower. So it depends on what your trade-offs are. There is something called collections. Nice to know about. We also have a bisect. So scores, they give scores to each one of these programming languages. And bisect insert scores 300 Ruby. Okay, that just it sorts everything and puts in another score. Okay. Bisect. And what it does specifically is manipulates sorted lists. Heap queue. This is useful for applications which repeatedly access the smallest element but do not want to run a full list sort. So we have some stuff imported from heap queue and data 13579244680. Heapify data, rearrange the list into heap order. Heap push pushes data in as a new entry, and heap pop data for I in range of 3. So the first 3 elements are -5, 0, and 1. So what this did was ordered everything and added some new data and popped it out, the first 3 elements in that data. Decimal floating point arithmetic. All right. So if you want to do rounding, you can import decimal and specify decimal points with formatting using the same. So you can see here, decimal, you put in a string and that turned it into a decimal with this function here. You have round, which was used above, so you can round a number to however many decimal places you want. And you can have as much precision as needed. Well, that's really it for the standard library part 2. So we kind of blew past all of that. So the next thing that we would be learning about here is virtual environments. Not exactly sure what that is. Packages, okay. So apparently you can create virtual environments and do a few things. I think next time. Oh, this is the very last section in the entire yeah, then you have a what now. Well, maybe tomorrow then we'll go ahead and finish this virtual environments and packages, and then I'll just open it up to a Q&A. You can ask questions about Linux or programming, and yeah, how does that sound? Maybe we can go through some questions, answers about the series, as well as programming in general, maybe C, C++ stuff, Linux stuff, all that fun stuff. And we'll just get a moment to talk, as well as finish up the last, the last chapter, it looks like, and talk about what now and what we'll do. All right. Sai looks like he's down, so let's do that. Tomorrow, I'm going to go and post a link so you know what time. I'm going to try earlier tomorrow. And that's really it. Thanks for joining, everyone. I hope you did enjoy this stream of going through the python.org tutorial. And next time, we're going to go ahead and talk about virtual environments and packages. It shouldn't take us long. There's not much there. And then I'm going to go ahead and open this up to a Q&A where we can talk about programming Linux or engineering topics or whatever. We'll just make it a free Q&A kind of deal. See what kind of questions I can answer. And then I will talk about the first project that I guess we'll do with Python. Also, keep a lookout for all of these tutorials getting placed together. I'm going to go ahead and go through them and see if I can't cut out all the dead space, all the little back and forth and stuff like that, and see if I can push this all together so someone can go through the entire tutorial on python.org with me and follow along. C++ sounds nice. Yep, perfect. All right, we'll talk C++ a little bit. And if you haven't already, check out my latest video. I think it's the complete C and C++ 10 episode series all mashed into one for your convenience. And no problem, Mitsu. I'm so glad you could make it today. I will catch everyone in the next one who shows up, of course. Thank you, everyone, for watching. I'll talk to you later.